we may have found evidence of powerful civilization. Extraterrestrial life has always been a controversial topic for the whole world. Scientists have launched many missions into space to back up their claim of aliens in space. Recently, there has been a breakthrough in this field. So what is the evidence scientists found? And are the aliens present in our solar system? Let's find out. In this video, we will look at the recent revelations on the solar system's exoplanets and what the satellites found on them. According to the Kardashev scale, there are three forms of civilizations in space. Level 0, or Type 1, represents the system that can consume energy only from its planets. Level 1, or Type 2, represents the system that consumes energy from the nearby star, and Level 2, or Type 3, represents the system that can consume energy from the galaxy. Our Earth has not even achieved the level of Type 1. Who knows, we might have a Type 2 or even a Type 3 civilization in space. There are still a lot of studies that need to be done on this topic. Since the discovery of the first exoplanet, many advancements have been made. Exoplanet research has reached a pinnacle after 3 decades of exponential growth. The Kepler Space Telescope and the Transiting Exoplanet Survey Satellite TESS, two instruments used to search for exoplanets from space, were created in response to findings made by telescopes constructed on the ground. It took these instruments a few years to reach full production, so we now have a technical window of opportunity. Second, there is a growing exoplanet community. Only a few people were employed in the field 30 years ago, and they were unsure of its future. The community has now grown significantly. Third, the idea of what to do next has been carefully considered. The origin of life and the existence of life elsewhere in the universe are two clearly defined major problems. We have a great chance to use multidisciplinary methods to find answers to these concerns by fusing Earth and planetary science, astronomy, biology, chemistry, and physics with ground-based and space-based observatories. In the course of a 2-year study, TESS completed its primary objective by imaging nearly 75% of the starry sky. In the process of collecting this massive mosaic, TESS discovered 66 new exoplanets, or planets outside of our solar system, as well as almost 2,100 candidates that astronomers are attempting to confirm. So does one of these planets contain life? The answer is that we don't know yet. But scientists have found some evidence that hints toward an advanced civilization. Scientists claim that there are superplanets that are more suitable for life than Earth. According to experts, a planet's mass and size can also have an impact on how well life can exist there. A rocky planet that is bigger than Earth would likely have a thicker, more stable atmosphere and a more livable surface area. A planet that is around 1.5 times as massive as Earth would likely retain its internal heat for a longer period, which would help keep its core molten and its shielding magnetic field active for a longer period, increasing the possibility that life may develop there. Superhabitable worlds could exist on worlds that are roughly 8 degrees Fahrenheit, 5 degrees Celsius warmer than Earth, because they could have larger tropical zones, which on Earth support greater biodiversity. Warmer planets may also require more rainfall, though, as increased heat may cause deserts to spread. Additionally, planets that are divided into smaller continents and have the same amount of land as Earth may be more habitable. The innards of the big continents are frequently enormous hostile deserts when they grow extremely massive, like Earth's former continent, Gondwana, which existed 500 million years ago. Scientists believe that planets with shallower seas may be able to host more life and allow it to evolve because Earth's shallow waters have a higher biological richness than its deep oceans. In total, Schultz-McCook and his team found 24 planets that might be very habitable. None of these planets satisfied all the standards the researchers established for super habitable planets, although one of them, KOI 5715.01, did meet at least 2 of them. A planet 1.8 to 2.4 times the size of Earth, orbiting an orange dwarf 2,965 light-years away, is known as KOI, Kepler Object of Interest 5725.01. It is thought to be roughly 5.5 billion years old. If it contained more greenhouse gases than Earth to trap heat, It might be super habitable despite having an average surface temperature that is around 4.3 degrees Fahrenheit, 2.4 degrees Celsius lower than Earth's. From these 24, KOI 554.01 was Schultz's personal McCook's favorite, potentially super habitable world. This planet, which is 700 light-years away from Earth and has a diameter between 0.72 and 1.29 times that of Earth, is roughly 6.5 billion years old. These 24 conceivably super habitable planets are all located more than 100 light-years away from Earth. They are too far away for NASA's Transiting Exoplanet Survey Satellite, TESS, to obtain high-quality photos to gather further information about them. However, Schultz-McCook pointed out that future spacecraft, including the recently launched James Webb Space Telescope, the NASA LUVOIR Satellite Observatory mission IDEA, and the European Space Agency's Plato Space Telescope, could provide information about these planets. The best chance to discover extraterrestrial life is on Europa, a moon of Jupiter. The smallest of Jupiter's 4 big satellites, this brilliant, strange-looking moon currently draws more scientific interest than any other body in the solar system. Io, Europa, Ganymede, and Callisto are depicted here from top to bottom, and as you would approach them going outward from Jupiter. Europa appears to be a wise choice, though possibly not much stranger than the living forms recently discovered near hot vents in the abyssal ocean. Life may be a little unusual. Energy sources and liquid water are required conditions for life. They might exist in Europa. Strong tidal heat may keep Europa's interior warm enough for liquid water to exist beneath an ice cap. Any organic substances would therefore be mobile in water. They might communicate with one another. The most prevalent components of known biological things like carbon, hydrogen, nitrogen, and oxygen are abundant on exoplanets. Even by the most elementary criteria, there are plenty of known livable planets. However, there aren't many visible indications of life. Initially, searching for circumstantial evidence of living species may prove more helpful. For instance, it is considerably simpler to sort through their footprints over vast, harsh terrain when you travel to the Tibetan Plateau in search of snow leopards. The abundance of atomic oxygen in the atmosphere is the most obvious footprint of life on Earth. These compounds are waste products of microbial life rather than essential components. During an Archean eon, biological processes significantly increased the amount of molecular oxygen in the Earth's atmosphere. The molecular oxygen in the Earth's atmosphere would rapidly decrease if we entirely sterilized all living forms on Earth at this time due to oxygen's high reactivity with other elements. Mars is a good example, where the oxygen corroded the iron on the surface, resulting in the reddish topsoil. As a biomaker, astronomers use molecular oxygen because it is reasonably simple to find. Even though oxygen does not frequently occur as free molecules in the atmospheres of most stars and planets, it is the third most plentiful element in the universe. It is not difficult to detect oxygen molecular traces in the infrared waveband. If they are present as ozone, they can even be seen as visible light. Most astronomers concur that there is a good possibility that if we find a planet with a lot of molecular oxygen in its atmosphere, that planet probably has carbon-based life on its surface. If a planet has an ozone layer in its atmosphere, we could even be able to see remnants of it using ground-based telescopes in the interim. It was only last year that a phosphine molecule was found on Venus. Phosphine has been regarded as a biomaker, a likely indicator of life among the high clouds of the extremely hot Venetian atmosphere because it is largely produced by living things on Earth. Regarding the possibility that sulfur dioxide at the same wavelength could obscure the spectroscopic fingerprints, this claim was met with a chorus of healthy skepticism. Based on their observations and studies, several scientists completely rejected the marginal indications. Arguments of this nature are common in the scientific community. Carl Sagan, a pioneer in astrobiology, phrased it in this way: extraordinary claims deserve extraordinary evidence. We must agree on a precise definition of life before we begin our haphazard search for evidence of extraterrestrial existence. Creatures capable of self-assembly and self-reproduction is an often used definition. According to this view, we are close to creating the first silicon-based life in the form of intelligent robots with biomakers that are entirely distinct from those of carbon-based life. In addition to the technical difficulties in remotely detecting these organisms, imprints, or traces, it is still debatable whether these things qualify as life. Former U.S. Defense Secretary Donald Rumsfeld once distinguished between known unknowns and unknowns unknowns, or those we don't even know we don't know. This query is classified as an unknown unknown. I believe that to find life, we should likely begin with the known unknowns and move forward incrementally. Because we are familiar with what to look for, it's always simpler to start by searching for life similar to that on Earth. Give thought to this evidence and share your thoughts with us. Like, share, and subscribe to the channel to know interesting information.